Hi dear students, I welcome you all. I am Dr. J. Chandrasekhar, lecturer in physics from Government Degree College, Rajam. In the last lecture, I have discussed about principle of conversion of solar radiation into heat and various collectors used for solar thermal conversion and especially about flat plate collectors. I hope you enjoyed a lot with the experiments, and today's lecture I will be going to explain about concentrating collectors. So, what is meant by solar collector? The solar collector is a device which is used to collect and absorb the solar energy radiated from the sun. And it is an essential device for converting solar radiation into heat energy or electrical energy. And these solar collectors are mainly classified into two types. They are non-concentrating collectors and concentrating collectors. Non-concentrating collectors receives solar radiation over a wide area, and the absorbed area, that is the area in which solar radiation absorbed, is equal to the collector area. So collector area and the absorbed area is equal for non-concentrating collectors. The example for non-concentrating collector is solar flat plate collector, and in the previous lecture I have completely discussed about non-concentrating collectors, that is flat plate collectors. So now I am concentrating about the concentrating collectors only. So what is concentrating collector? As the name indicates, in this type of collectors, solar radiation will be concentrated to a smaller area. So, even if the radiation is collected over a wide area, the collector radiation is concentrated to a small area. So, here collector area will be very much greater than that of the absorbed area. So, the radiation falling on a relatively larger area is focused onto an absorber of considerably smaller area. Let us see how the solar radiation is concentrated or focused at a particular point. Let us assume this is sun and the radiation coming from the sun is incident on this collector. Assume this is a collector, but actually it is a lens. So after refraction, all the rays focused at a particular point. So this is focal point of this lens or the collector. See, the collector area is large and the focal area is very small. This is one parabola. It is a parabolic mirror, and here also when the sun radiation is coming from the sun is incident on this parabolic mirror. Clearly observe, since it is a mirror, it reflects all the radiation. So see here, the reflected rays are coming and focused at point. It is at 2.5 centimeters. So this is the focal point of this parabolic mirror. And if the sun rotates, the focusing point also varies. But here I am fixing here that the focusing point is always fixed. So in real life also, to concentrate the sun radiation, we need tracking of the sun. Here also collector area is large and the focusing area is very small. It collects solar radiation with a high intensity, so that the radiation collected over a wide area is being focused over a small area. And since they have concentrate solar radiation at a particular area, they use optical system in the form of reflectors and refractors. Non-concentrating collectors collects both direct as well as diffuse radiation, whereas concentrating collectors collect direct radiation only. Requires tracking of sun. As sun is rotating, the focusing point of the radiation flux continuously varies, so it requires tracking of the sun. And The concentrating energy, if concentrates or focus on a point, then it provides high to very high temperature. If the concentrating energy focus on a line, then it provides moderate to high temperature. If the concentrating energy is non-focusing, then it provides low to moderate temperature. So, as entire solar energy is concentrated at a smaller area, the fluid can be heated up to a temperature of about 1000 degrees centigrade, and the heat transfer fluid will get very high temperature. So, these are suitable for high temperature applications. Now coming to the parts of concentrating collectors, it mainly consists of focusing device, receiving device and tracking arrangement. See in this figure, this is focusing device also known as concentrator, and this is receiver, and this one is two-axis tracking mechanism. This concentrator focuses the solar radiation which falls on it to the receiver, and the receiver receives the reflected solar radiation from the concentrator and converts it into heat. And as these collectors collects the direct beam radiation and focuses towards the receiver, and as the sun rotates, so the focusing point is also always varies. So it requires tracking of the sun. So for that purpose, here is the tracking mechanism, two-axis tracking mechanism. That means it can move left to right and also up and down. Now coming to the working principle. See in this figure, this is a concentrator also known as reflector, and this is a receiver. When the solar radiations incident on this reflector, then they get reflected. So these reflected radiations are concentrated on focal point or the focal axis. This one is a focal axis for this device. So at focal point or the focal axis, there is a receiver which carries fluid to be heated. Due to solar radiations, fluid gets heated to a high temperature. So the heat is then transported to a steam generator where it is converted into electricity. So in this way, solar energy is converted into heat or electrical energy. Basing on the focusing type, the concentrating collectors are mainly classified into two types. The first one is line focusing and the second one is point focusing. In line focusing, the line is a pipe collector, and in point focusing, the point is a small volume. The examples for line focusing collectors are parabolic trough collector and Fresnel lens collector. And the examples for point focusing collectors are parabolic dish collector and central tower receiving collector. Mostly we are using these collectors, so now we will discuss in detail. The first type of concentrating collector is the parabolic trough collector. As the name indicates, here the heat collecting area is in the form of parabolic trough. Trough means an open vessel. So here the optical system or the part which collects the solar radiation will be in the form of a parabolic trough. It will be made up of curved mirror segments forming a parabolic shape. This is the one mirror segment and this is another mirror segment. So when solar radiation falls on this parabolic trough, the entire sunlight is reflected and focused onto the focal line of the parabola. So this will be the focal line of the parabolic trough. So the entire light will be focused onto the entire focal line of the parabola. So we will place the absorber along the focal line of the parabola. Here it collects direct radiation. So to collect direct radiation, they should always be oriented along the sun's rays. So they should need a sun tracking mechanism. This is the animation showing working of the parabolic trough collector, and this is the parabolic trough shape. These are all mirror segments joined together to form parabolic trough shape, and this is the focal line of the parabolic trough. The entire solar radiation falling onto the parabolic trough is focused onto the focal line of the parabola, where the heat transfer carrying tube and the absorber are placed. And in order to collect maximum solar radiation, this parabolic trough has to be oriented along the sun's direction. As the sun moves, we have to change this orientation of parabolic trough along the sun's direction. Now let us see the experimental demonstration of parabolic trough collector. So this is parabolic trough. As the name indicates, the solar collecting radiation surface is in the form of parabolic trough. So when the solar radiation is incident on this surface, then the entire solar radiation reflects and focus at that focal line of this parabolic trough. So if we place the absorbing receiver at that focus line point, then we will get high temperature. So that we will see by using this. I placed this parabolic trough here, and you observe this how the radiation is reflecting from this parabolic trough, and here is the focusing point. Now I am changing the position, then the focus point is also changing. What does that mean? The sun as rotating, the focus point is also rotating. So that's why we need the sun tracking system for this parabolic trough also. So here I am placing exactly towards the facing of the sun, then I am getting more intensity light point. Here is the more intensity. It is exactly, see, the 2.5 centimeters. It is focusing all the radiation at that point. So if we place it the absorber receiving pipe at this point, then we will get high temperature, which is used to heating the liquids. The next line focusing concentrating collector is Fresnel lens collector. So this is shown in this figure, and in Fresnel lens collector, linear grooves are present in one side, while other side it is a flat surface. So when the solar radiation incident normally on the flat surface, after refraction all these rays are focusing at the focal point. If in that focal point, if we placed the absorbing tube containing heat transfer fluid, then the working fluid in this absorbed tube gets heated to a high temperature. So in this way, Fresnel lens collector is working. Now let us see the experimental demonstration for this Fresnel lens collector. So in that Fresnel lens concentrating collector, linear grooves are present at the one side of the lens, and the other side is completely flat surface. So when the solar radiation coming from the sun incident on this flat surface, after refraction all the rays will be concentrated in this direction and focused at one point. So at that focus point, if we place the absorbing receiver, then we will get high temperature. So that we will see in this experiment. So for absorbing receiver pipe, I have taken as one copper wire, and this is placed here like this, and instead of Fresnel lens, I have taken an ordinary lens, and I am focusing the sun radiation on this pipe. Assume that this is one copper pipe, and I am placing one thermometer which is in contact with this pipe. So let us see the initial temperature of this copper pipe. It is around 35 degrees centigrade, and it is slowly increasing. It is now reaching 36 degrees. It is slowly increasing because of we are doing this experiment morning 10:30 a.m. So in this way we are getting more temperature by using Fresnel lens concentrating collector. Next one is the parabolic dish collector, and it is the example for point focusing concentrating collector. As the name indicates, the heat collecting surface is in the form of parabolic dish. This is the parabolic dish, and it will be made up of around 200 curved mirror segments which acts as a collector. This dish will be having a diameter of about 6 to 7 meters. This is the diameter, and this is the collector, which is made up of mirror segments, will focus the entire light towards the small area where the absorber is placed. So this is the absorber. As it is also collected direct radiation only, so we have to orient it always sun's direction, and this dish can be rotated in two axes, and it can have either up or down movement or right or left movement. So we can suitably align this dish always towards the direction of the sun. This is how an actual parabolic dish collector looks like, and this is the collector and this is the absorber, a small volume. So when the sun radiation incident on this collector, it reflects and focusing towards this absorbing receiver, and the fluid inside the absorber heated to a high temperature. Now let us see the experimental demonstration. This is parabolic dish. As the name indicates, the solar radiation collecting surface area is in the form of parabolic dish. So when the sun radiation is incident, then the entire solar radiation is reflected and focusing at the focal point of this parabolic dish. So if we place the absorbing receiver at that focal point of this parabolic dish, then we will get high temperature. So that we will see by using the black paper. So now I am placing this parabolic dish like in this form. So you observe that this is the reflected radiation coming from the sun. So when the sun is radiation is incident on this parabolic dish, you observe that the reflected radiation focus point is here. Now it is here. As I am rotating this, the focusing pointing also is changing. So what does that mean? As the sun rotates, the focusing point of the reflecting radiation is also rotates. So that's why we need the sun tracking system. So here I am focusing all the radiations at some point. You cleanly observe this one. Yeah, this is the maximum focusing point, this one. As if we place the receiver here, then we will get the more temperature. The last one is central tower receiver collector. It is also called as solar tower collector. In the central tower receiver collector, there will be a tower located exactly at the center of the plant, and the top of the tower the receiver is placed, and on the ground surrounding this tower there will be thousands of flat mirror segments arranged. They are known as heliostats. So on the ground around this tower, the large number of moving flat mirror segments are arranged in such a way that the radiations falling on it at any instant is focused onto the receiver. Alignment of these heliostats can be varied according to the sun's direction. As there are thousands of mirror segments that concentrate light onto the point, we will get very high intensity of sun's radiation and a very high temperature attainable here. Now the heat transfer fluid will float towards the receiver and will get heated and then flows back through the pipe, and that heat can be used to produce steam for driving turbines and for produce mechanical energy or electrical energy. This is the actual central tower receiver plant looks like, and these are the heliostats. Number of heliostats are arranged here, and this is the central tower, and top of this tower this is the receiver. And now we will see the experimental demonstration of this solar tower. Now coming to the solar tower or central tower receiving collector. Imagine this is a solar tower and top of this tower there is an absorbing receiver. So this tower is located exactly at the center of the plant, and around this tower there will be thousands of mirrors placed, and these mirrors, as the radiation incident on this, all these mirrors reflects the radiation towards this absorbing receiver. So when the absorbing receiver is in contact with the fluid, that fluid will be heated to a high temperature. That we will see. So now I am placing this solar tower here, and this is a thermometer which is in contact. Just I am placing that these two are in contact with each other. Now let us see the initial temperature of this one. It is around 38 degrees centigrade. Okay, so now by using these reflectors I am focusing the sun rays towards this absorbing receiver. So see how the radiation is focusing. You observe here, this one is the focusing point of this reflector. Now this I am changing the position and focusing towards the absorbing receiver. See here, it is exactly focusing on that absorbing receiver. And similarly I am taking another reflector which is used to focus the solar radiation at the same absorbing receiver. Yes, so since both these two mirrors are focusing exactly on the absorbing receiver. Now let us observe how the temperature of this absorbing receiver increases. You cleanly observe this one. Now it is around 42 degrees centigrade crossing. It is initially at 38 degrees centigrade and now it is 43 degrees centigrade. See how rapidly it is increasing. Why? Because I am doing this experiment exactly in noon hours. That's why it is increasing rapidly. Now it is approaching 45 degrees. So by using only two reflectors we are getting more temperature. So if we use heliostats, that means thousands of mirrors are focusing at the receiver, then how much of temperature we will get, you just imagine. Now let us see the advantages and disadvantages over a flat plate collector. Even though absorber area is same for both, but in concentrating collectors all the radiations are focusing at same point. Hence we are getting high temperatures. Heat transfer rate is very high. Here very rapidly heat can transfer to the fluid, and these collectors produce both electricity and heat. Also it doesn't require anti-freeze protection, since these are maintaining constantly very high temperatures, so there is no need of anti-freezing protection. Now coming to the disadvantages, only beam radiations can be used for energy conversion. Diffused radiation is not using here. Here the energy flux continuously varies, so it requires sun tracking system. And due to complicated construction, it is more expensive. And due to dust and moisture on the reflector, the efficiency reduces. Hence, it requires frequent cleaning. So, it requires regular maintenance. So dear students, we did all these experiments for demonstration purpose only. You can do these experiments at your home with innovative new ideas. Thank you.